Okay, so what we're concentrating on today is the intermediate value theorem, IVT. Okay, conceptually, it's easy to understand, but all these variables that we're going to be using, sometimes it might seem a little bit difficult, but it's not. We're going to have plenty of practice for group bonus points today, okay? Now, let's go ahead and start with IVT. IVT is a theorem that if these three satisfy and are true, then this is my therefore, okay? Remember, we did therefore with continuity. So if this is true, and this is true, then this is a must exist, okay? There must exist a number C between A and B for which f of C is equal to K. And all these letters, it's like, man, what does all this even mean? Okay, so let's break it all down as we go through. First of all, f of x is continuous on the closed interval a to b. In other words, it has two endpoints and it's continuous in between. You with me? Okay. As we do this, I want to see what that looks like to you. So here's A, here's B, and we're saying at A there's a closed point. We're saying at B there's a closed point. Could even look like this. At A you could have negative closed point. At B you could have a positive closed point. Now what I want two people who I will call on to do is you're going to come up here and just draw a continuous function. Anything that you want that is in between A and B. Kevin, come on up. So his goal for the first graph is just to draw a continuous function between A and B. Thank you. Everyone, was that continuous? Yes, because why? He didn't pick up his pencil. You with me? Any questions? Now, John, come on up. I want him to do something drastically different that still is a function and is continuous. Go for it.
Drastically different?
Yep. That's still a function and continuous.
So, like that.
Okay.
Is that drastic enough?
That's good. So this is still a function and it was continuous. What I was kind of looking for would be something that would look like this. Here's A, here's B, and here's a function like that. You with me? Continuous from endpoint to endpoint, and it passes the vertical line test. Are we good? All these are subtle but huge and important to make this easy, okay? Okay. So now, condition number 2. F of A cannot equal f of B. Okay? Matthew, what does that mean in layman's terms? In simple terms, pretend I'm in 3rd grade. Tell me, what does that mean? Break it down to a 3rd grader.
The y when it's at A cannot equal the y when it's at B.
Perfect. Okay? Let's say another description. Lexi, what would you say to a 3rd grader? Simplify it. F of A does not equal f of B. What does that mean?
That their y values are different.
Perfect. Even more so. Both of them together build perfect. Y's are different. The y at A does not equal the y at B. Are we good? Okay. And you saw that, guys, because look, this right here is f of A. This right here is f of B, aka the y value at B, the y value at A. Down here is f of A. Up here is f of B. Same thing. Up here is f of B, and down here is f of A. Simply put, y's are not equal. Go with me? Okay. So now let's go to the third and final condition. If K is between f of A and f of B, Spencer, what does that mean? If K is between f of A and f of B? Layman's terms to a third grader.
If the number is between the y of A and the y of B.
Perfect. If that number is in between the y at A and the y at B. You with me? Madeline, what else would you say?
Would it be a constant? So, like a point on the graph in between A and B.
Okay, so this right here is a good misconception. Let's think about this, because it's going to lead to that. She's a little bit ahead of us right now. Everyone needs to answer this. What kind of value is K? The y value. Put that in your brain right now. K is a y value. And it is in between the other two y values. Are you with me? So here we go. K, let's do this in purple, is going to be somewhere in between. Notice how I have open dots? Let me make that a little bit clearer because that is disgusting. Alright, let's do it like this. K cannot be f of B, K cannot be f of A, but it has to be somewhere in between. Not here, but somewhere in between. So if you need to write it down that K is a y value, please do so. Because the variables is what trips people up. Okay? So if K is in between f of A and f of B, then there must exist a number C between A and B. Let's break that down. C is between A and B. Everyone, what kind of value is C? An X. Write that down. C is an X value. Now I'm going to do C in orange. So in between A and B, there's going to exist a C. In between A and B, there's going to exist a C, an X value. Okay? There must exist an X value between A and B for which the Y value at that C is equal to K. You with me? Here we go. Visually, let's say that K was right here. Let's say it's 5. So Y equals 5. You with me? So it's saying there must be at least one number, in this case, it's right here, C, where if I found the Y value of this, which is K, it's saying that there will be a C value that exists between A and B. Let's say over here that K was like -3. Otherwise, Y equals -3. It's between f of A and f of B. Then it guarantees that in between A and B, there will be a value. Now, I know the graph might be a little bit too steep. No worries. But we could draw something like this. And here's the value that I'm wanting you to look at. So let's erase this so it doesn't confuse us. No, you're good. And you see that that value is going to be about right here. We're going to call it C. It's in between A and B, where that Y value will equal this K. Please ask me if you don't understand. Please don't be shy because this is a big part of the proof. Yes?
So it's just any points between like the C and the K that line up?
Any point between, yeah. So let's look at this last one. That's why I did the drastic one, okay? So let's say that K was right here. And let's say that K is equal to, let's say again, 5. Guys, how many C values between A and B would this satisfy? 5. 1, 2, 3, 4, 5. So you would have C1, C2, C3, C4, and C5. At most, you're going to see is like 2. You with me? Any questions on what this works? or how this works. Would this work if this was discontinuous? Would it guarantee that there must be one, yes or no? No. Because I could have drawn something that looks like this. Straight, jump, done. I never crossed that k value. I never touched it. You with me? That's why rule 1 needs to be continuous. Could I fit a k in between f of b and f of a if I had a graph that looked like from a to b, let's say that was a straight line. Here's a, that's f of a. Here's b, which is still the same value as f of a. Can I squeeze a k in between a number itself? No, there has to be some interval that exists. That's why f of a cannot equal f of b. I got to be able to fit something in between. Does that make sense? Are we good? All right. So now let's go to the proof and then actually do this with problems. Okay? So in other words, a function y is equal to f of x that is continuous on a closed interval a to b takes on every value between f of a and f of b. If k is between f of a and f of b, then there is at least one c, and this should say on a to b for which f of c is equal to k. The hard part is writing and describing all the stuff that we just intuitively easily see. Here we go. So I'm going to establish the expectation immediately, okay? Use the intermediate value theorem to show that, oh, and by the way, we're going to have 6 problems to do in groups for bonus points, and they're going to be at stations. And we're going to have like 4 to 5 minutes each station where you're going to do the problem. Then you're going to go with your group, you're going to go to the next station, and so on and so forth. And it's almost like a round that we're going to do, and you're trying to get the most bonus points from all these pieces, okay? And at the very end, I'll show you the solutions to all of them, and you can grade and see how many points you earn. Okay. So use the intermediate value theorem to show that this function takes on the value 1 for some x in the interval from -2 to 4. Guys, what kind of value is this? Y value? So you could say, let k equal 1. Okay? Now we've got to graph this. Let's go back to pre-cal a little bit. By hand, without a calculator, if I GCF out an x, I would have this. You'll see it? And if I factored out the difference of squares that you see, so there's a lot of review, for sure, what would the factors be? Nice. Those are the factors. So on a graph, I'm going to go over here, and guys, root 3 is between root 1 and root 4. Would you agree? And root 1 is 1, right? And root 4 is 2. So it's somewhere in between 1 and 2. Are you with me? Okay, so this one is like x is equal to negative root 3. So between -1 and -2, it's somewhere here. This one is x is equal to a positive root 3, which is between 1 and 2, somewhere here. And I still have this one right here that's x is equal to 0. I know it's been a minute, but we have to remember how to draw these by hand without a calculator. If I FOILed all this out and distributed, I know I have a positive coefficient with my leading degree. My highest degree has a positive coefficient. So as you go to infinity, it will go up. Because this number right here is an odd number, as I go to the left, it's going to do what? Go down. Nice memory. And it will cross through these because, look, x to the power of 1, x to the power of 1, x to the power of 1. It's not going to bounce. It's going to go through. You with me? Remember when we graphed this in pre-cal, So we'll start from here, go through, go down, and go through, and it looks something like this. Okay? Alright, so now let's move on to the theorem. Number 1. Is f of x continuous? Yes. So here we go. F of x is continuous on, please use the word on, what? -2 to 4. Should I use parentheses or brackets? Brackets. Important. Important. Everything in blue is important. Because if it's different, it will be wrong, okay? Number 2. What do you think I'm going to write? Okay, so now we got to be careful because A and B have values right now, don't they? What kind of values are these right now? They're x. They're both x. A is x1. B is x2. So you could say f of -2. You have to ask yourself, are they equal or not equal? You with me? So how are we going to find that? We're going to plug those into the original equation. -2 cubed minus 3, -2. Can someone tell me what that answer would be? -2? So this is like -2. Let's plug 4 into the built function. Oops. So we're going to plug 4 in where x would go. So 64 minus 12, what would you get? 52. Guys, is 52 equal or not equal to -2? It's not. I want you to show this work off to the side, but don't include this in your proof. I want you to show it like this. Encoded, it's -2 is not equal to 52. Okay? Alright, so now, oops, let's go to rule 3. Remember, you have to check. And remember, if any of these are false, then the theorem does not hold. Therefore, there must not exist. You know what I mean? It doesn't have to exist. A C, and so on and so forth. We want them to all hold. So good, good. Rule 3. Can you fit this k value of 1 in between -2 and 52? Yeah, it does fit. So we're going to, just like you have on the proof up here, watch up here, if k is between f of A and f of B. So let k equal 1. And we're going to say k is between f of -2 and f of 4. Off to the side, if you want to say k equals 1 is between -2 and 52, you can if you want. But don't put it over here in the formal proof. Alright? Alright, here we go. So check. So therefore, there must exist a C value on -2 to 4, parentheses or brackets? No. Parentheses. Because it can't, just like f of A cannot equal f of B, this C cannot equal A or cannot equal B. You with me? It's going to be in between. So there must exist a C value on -2 to 4 where f of C, careful, is equal to what? 1. Nice. So let's go to the graph. We could say 1 is here. So y is equal to 1 or k is equal to 1. Same thing. How many answers do y'all see? Because we're looking at from -2 to 4, open, open, and everything in between. We see 3. There's 1 right here. See 1. There's another one. See 2. Okay, I stand corrected. Sometimes you'll have more than 2. See 3. Are you all with me? Okay. So use the invariant to show takes on value for some x. Now what if I asked you to solve for that x? Like right now, you would get points like this. You get 1 point for this, another 10, another 10, with the k, there's another 10. Then you'd get this k, oh no, I already wrote that down. The graph, this would be a point, and then the graph itself would be another point, like the curve. Okay? Now, and then the last point will come from actually solving where k. Solving for those c's. Here we go. So the last part is this. Let me make some room so that you can see it clearer. The last part we're going to do is this. F of c, let's watch carefully because people are like, why do we even do this? But it's the proof. F of c is equal to c cubed minus 3c. You with me? What's f of c? 1. Nice. It's k. It's 1. And all we're going to do now is what? Solve for c. So we'll say 0 is equal to c cubed minus 3c minus 1. And you're probably thinking to yourself, how do we factor this? How do we factor something without the calculator that looks like that? So it's been a minute. Let's go back a little bit to pre-cal. And the first and the last will be multiplied. Right? Do you remember, Evelyn, what I said last year on this? No? No. All right, so 1 times -1 will be a -1. So I want you to think of -1's factors. It's just 1 and 1, right? 1 and -1. So we're going to do synthetic division. Okay? Synthetic division is going to use this equation, and we're going to use the coefficients to solve for the factors of 1. All right, here we go. So we have 1, 0, because there's no square term, -3, and -1. And we're going to test out either a positive or a -1. Okay? Because again, how do I know what to test? Because the first coefficient and the last constant multiply together is that. So what are the factors of -1? So let's try 1. We copy, multiply, add. Multiply, add. Multiply. I did not get 0. So x is equal to 1 is not a factor. You with me? So again, x is equal to 1 is not a factor. Otherwise, the binomial, this is not a factor. A lot of review. So what we have to try, since that one didn't work, would be what? -1. So -1, we're going to copy this first one, multiply, add. Multiply, and then -2. And then multiply, and we get what? 2. I still didn't get 0. So if they worked out and I was able to get it, then I'd be able to further factor from here. But because of this, this is a calculator problem. You with me? So this would be a calculator problem. To real quick, I'll show you what that looks like. It would look like the following. So let me real quickly sign on. Bless you. And we're going to find my calculator and show it. And we have, so 1, no, it's x cubed minus 3x minus 1. Please remember that, okay? So we'll go to the calculator, and I'll show you how to find it. You can use C if you like. And I'll say menu 3-1. Solve when 0 is equal to, Adam, what was it?
X cubed minus 3x
Okay.
minus 1.
Okay, so I put C. I went ahead and put C because you can put any variable. And I wanted to solve for C. So I'm going to do comma C. There's my answers in fraction form, but we need to get in the habit of always doing control divide. And there they are. Not control divide, sorry, control inner for decimal answers. So C is equal to negative 1.532. C is equal to negative 0.347. And C is equal to 1.879. I know I threw a lot at you on that first one, but it's a lot of review and a lot of stuff that you're going to do by hand as well, okay? Questions? Yeah.
Can you just scroll up a little bit so I can see what you put in for the...
Oh, sure. So menu 3.1 will give you a solve feature, and then you type that in. Real quick, check this out. Control C, I can copy this, and down here, let's say that I did not menu 3.1 to solve, but menu 3.6 in solve. And then I did control V to paste. Now check this out. You're going to be learning the calculator all year. Don't be resistant, I promise, because the earlier you do it, the better it is for you test-wise. It would only, control enter, give me one answer. The CX model that is not the CAS will only give you one answer. But the CAS, which is allowed on everything except the ACT, you can have multiple answers with the menu 3.1 solve feature. Are we good? Questions before I keep going? Okay, so let's go back to that example. And those C values would be points that you're going to get today. So 3, 4, 5, 6, 7, 8. That would be a 160-point question. If you got it perfect. Okay? All right, let's keep going. And then we'll practice a lot. Trust me, we're going to practice a lot. So your instructions are this. Determine if the intermediate value theorem holds for the given value of f. If the theorem holds, find a number c for which f of c is equal to k. If the theorem does not hold, give the reason why. You could say because f of a did equal f of b, or you could say f of x was not continuous on the interval, just different things. And then we want to draw a sketch and actually go through. Okay? A lot of points up for grabs right now. We're going to go ahead and start. Before the stations, we're going to do a couple with your groups before you guys start rotating around. Okay? So go for it. I will give you, let's say, let's go 7 minutes for this one. I will work it out back there as you're working in groups. Please do talk. And I will see you in just a bit. 7 minutes. So back to the recording, The first example problem that we have is this 1 over x minus 2. We're trying to determine if the theorem holds. We're trying to, if it doesn't give a reason, we're going to draw it as far as a graph. All the pieces that you see. So we're doing number 1. Here's the solution. So the solution, oops. Okay, so let's keep recording. This is the solution right here. Now, I graphed it. Notice that it was a shift 2 to the right. Is this function continuous right now? Like the whole function? It's not. However, I did put a check on here because it is continuous on this defined interval. So if you wrote this down exactly the way pretty much that I have it here, give yourself 10 points. Yeah.
Does it matter if it's an x value or the y value?
Can you explain that again?
Like, it doesn't matter if I put 2.5 and 7 or the y values that you calculate later.
Oh, they have to be the x values, yes. Okay? So these have to be the x values 2.5 closed to 7 closed. Second rule. F of 2.5, which is 1 over 1/2, which is 1 divided by 1/2 is the same as keep, change, flip, 2. This is my scratch work, and 1/5. Yep, that's true. 2 is not equal to 1/5 or 1/5. So I can fit something in between. Okay? So the third one is let k equal 1/4. So with this being said, is k between 2 and 1/5? But I don't want you to write it like that. I want you to write it what you see in blue. 1/4 is between f of 2.5 and f of 7. Means the same thing. And then therefore, there must exist a c value on 2.5 to 7. There's one of them, because I want those parentheses, because you're saying in between, where f of c is equal to 1/4. I want you to use c, not x. It's just the proof form. We know that c is still an x value. So please make sure you have that work somewhere. And then last but not least, c would be 6. And you see it verified that 6 is in between 2.5 and 7, where the graphs would actually intersect. So for the very last piece, you didn't even have to draw the whole graph. You could have only drawn this piece of the graph and you would have been accurate. Even more accurate, okay? So if you drew this graph, and so the horizontal line is a point. The graph is another point. Okay, so I'll just do it like this. So 2 points for the graph. One for the horizontal line, and one for the other one. So I have 1, 2, 3. Okay, I know that I highlighted or I circled this, guys. This is not a point. This is scratch work off to the side. So here we go. 1, so 1, 2, 3, 4, 5, 6, 7, and then the graph is 8, 9. 9 points, and the answer? The answer is just 1 of those 9. Okay? So out of that, team 1, how many did you get? Oh, let me, real quick.